Hey there, maths enthusiast. Welcome to our channel. Today I am so excited that we are going to explore one of the most fundamental principles in trigonometry. That is the sine rule, and I'm also excited to share with you a step-by-step proof that is very easy if you follow me in this video from the start till the end. We will be proving how to derive the sine rule. So before we do that, I want to show you how the sine rule looks like when it is derived. That's how it looks like. We've got sine A over A, sine B over B, and sine C over C. Don't worry if you don't see yet what is happening there. We're going to prove this, and I'm going to explain each and everything in details. Then there's another version of the sine rule that is flipped, and that's how it looks like. And I'm going to explain everything and how and when to use each of these two versions. Now, before we dive into deriving the sine rule, I want us to look at the standard way of labeling angles and sides of a triangle. In this triangle, we've got vertices A, B, and C, and those represent the angles of a triangle. And you can see that the letters are given in upper cases. Then we have letters that are written in lower cases, and each letter that is in lowercase, it is opposite the letter that is in uppercase. So that is basically how we label the angles and the sides of a triangle in a standard way. So angle A will be opposite side A, angle B will be opposite side B, and angle C will be opposite side C. Okay, now grade 11s, let us dive in and prove the sine rule. Now consider this given triangle, triangle ABC, and the sides ABC, which are opposite the given angles. Now grade 11s, we need to prove the sine rule, but the only thing that we know when dealing with trigonometry is using the trig ratios. That is the sine, the cosine, and the tangent ratios. And those ratios can only be used if the triangle that is given is a right angled triangle. So what we're going to do, grade 11, is we're going to construct our own right angled triangles because we need to use what we know. And what we know currently is the use of the sine ratios, which can only be used if the triangle that is given is a right angle triangle. So what I'm going to do now, I'm going to construct the altitude from one of the vertices. I'm going to use vertex A. I'm going to construct the line that is going to go down to side A and is going to meet side A at D, and making sure that that line is perpendicular to side BC, which is A, and that is now the base. And we are going to call this line H, which is the height of the triangle. Now grade 11s, what we have currently is what? Two triangles. We've got triangle ABD and triangle ACD, and these triangles, fortunately, they are right angled triangle. So we can use what we know. Since we are proving the sine rule, we are going to use the sine ratio and define the sine ratio in each of the triangles. So I'm going to start off in the first triangle, that is triangle ABD. So I'm going to say in triangle ABD, in this triangle, what I'm going to do, I am going to define sine, and I'm going to choose angle B as my angle of interest. So we know that sine is defined as the opposite over the hypotenuse. So what I'm going to do is that I'm going to use angle B, and the side that is opposite angle B is side H. So that is going to be H over the hypotenuse. We know that the hypotenuse is always opposite the right angle triangle, and our right angle is at D there. So which means the hypotenuse is side C. So that is sine B is equals to H over C. Then I'm going to go on and do the same in the other triangle. I'm going to go to triangle ACD. I'm going to say in triangle ACD, then I define sine also in here. I'm going to define sine using angle C. So what is opposite angle C? It's h again divided by the hypotenuse, and our hypotenuse in this case is B. Now this is what we currently have now. So what we're going to do here, we're going to make h the subject of the formula. Our altitude, we're going to make that the subject of the formula. So starting here on the left hand side, let us make h the subject of the formula here. How do we isolate h? We isolate h by multiplying both sides by c, or you can just multiply c over on this side. Then we're going to have h being equals to c sine b. Then we go on and do the same thing. Therefore on this side we also multiply b over, or we can just say multiply b on both sides. And reading the equation from the left hand side, your h is going to be equals to b sine c. Now we notice that we have got two equations that are equal. We've got two expressions that are equal. Then we're going to equate them. We're going to equate the altitudes. So as we know mathematically that two things that are equal, the same thing, they are also equal. So therefore we're going to have our c sine b being equals to b sine c. And that's what we have there. So now to eliminate the unknown here, the unknown altitude, what we're going to do is that we're going to divide both sides by BC. So I'm going to go on and divide this side by BC. Remember, we are formulating the sine rule, where C in this case is going to cancel C. Then we're going to be left with sine B over small letter b equals to sine c over small letter c. Right, now this is quite simple, but we have seen that the sine rule has got three parts and we've got one part that is missing. So what can we do? We can just say similarly, by constructing the line perpendicular to, let's say, AB. From the vertex C, we can construct the line perpendicular to side AB there, and then we can also prove by doing that. We can follow the very same steps, and we can also prove that sine B over B is going to be equals to sine of A over A. Then what we can do, then we can just write the sine rule in full, starting with sine A. So we're going to have sine A over A being equals to sine of B over B, and that is equals to sine C over C. And that's how you do that. That's how simple it is to prove the sine rule grade 11s. Then we look at the conditions that we have to know so that we'll be able to use the sine rule. Remember that the sine rule is used when dealing with pairs of opposite sides and angles. There must be pairs of opposite sides and angles because they are related, because that is basically what the sine rule does. It relates the sides to their opposite angles, or it relates the angles to their opposite side. So you only use the sine rule if you know the side and angle pair. That is very, very important. And what do we mean by that? It must be an angle and the side opposite it, and another side or angle must be given. If the angle is given, then it means you're going to calculate the side. If the side is given, then you're going to calculate the angle. So since you can see that we have got two versions of the sine rule currently now, the one with the sign of an angle in the numerator and the other one with the lower cases in the numerator. The one on the left hand side, you're basically going to use it when you're calculating the angles, and the one on the right hand side, you're going to use it for calculating the sides. And that is the end of the video, and I would like to thank you all for watching till the end. As you can see that we've proved the sine rule, which is quite simple. It was very easy to prove the sine rule. And thank you all for watching. Don't forget to subscribe for more videos that are going to be uploaded.